Imagine an anthropologist discovered a skeleton that's 30,000 years old. Now he has to figure out what species it is. To do this, he has two lists. One list of features for the Neanderthal, and one list of features for the anatomically modern human. Now he looks at the features on the skeleton, and he looks at his two lists, and he's able to match those features and figure out what species the skeleton is. It's pretty straightforward. But what happens if that skeleton doesn't actually fit within one species or the other? What happens if that skeleton is a hybrid? Well, we don't actually have any way of figuring out what a hybrid is in the fossil record, even though we know hybrids exist because of the living people today. Europeans and Asians have 2 to 4% of Neanderthal DNA in their genome. That's pretty much everyone in this room. So we know they exist, but we don't have a list of features that define what a hybrid is in the fossil record. But that's where my thesis comes in. I'm using baboons as a model for anatomically modern human and Neanderthal hybrids. I'm looking at CT scans of skeletons of two species of baboons, the yellow baboon and the olive baboon, and they're hybrids. By looking at a known skeletal hybrid, I'm able to create that list of features that are associated with hybridization, so anthropologists can take this into the field and identify hybrids in the fossil record. My list of features is composed of anomalies, or abnormalities in the way that bones develop. Anomalies develop because the timing of the development of the bones is different in the hybrids compared to the parental species. Previous research has identified these anomalies in external features, such as sutures or the joints between the bones in the skull and in teeth, and they only find these anomalies in the hybrids. My research is looking at internal features, such as the inner ear and the lateral recess, which develops into sinuses in humans. Internal structures are considered to be more developmentally stable because they're more critical to our survival. You can imagine if there's a problem in the development of your inner ear, you might have problems with hearing or with balance, which would be a problem for your survival. But internal structures have yet to be looked at in the fossil record or in hybrids in general. So if we go back to the fossil record, there are anthropologists that are looking at these skeletons and arguing over, is this skeleton a Neanderthal, is it an anatomically modern human, or is this a hybrid? And they have no way to figure this out. And my thesis will provide a new framework for analyzing these skeletons and any future skeletons in the fossil record to identify hybrids. Thank you.